Oh yeah, there we go. There's more light. Okay, there's more light. Okay. Sorry about that. Yeah, I forgot that when it turns white, there's more light. Okay, so stay, do that. All right. Well, I'm going to do another one of these big problems for you, the ones that have three equations, but I'll let you choose though. Would you rather do 13 or 14?
Oh, 14.
14? Are you positive?
Let's say 14.
I think 12 is actually sorry. Would you rather have me do, actually there's four of them actually. 11, 12, 13, and 14. 12, 13, or 14, which one do you want? Or 15 actually. Okay, who wants me to do 12? Raise your hand if you want me to do 12. 1, 2, 3, 4. How many want me to do 13? 1. Okay, 2. So 2. So who wants me to do 14? 1, 2. 1, 2. Who wants me to do 15? So I think 12 actually wins. Is that all right? Okay, so 12. 12. Okay, so number 12 says we have 6x. Make sure you're taking notes because the only way to learn through it is to actually like work through it and follow along when you're doing it. It's just like learning how to do like play basketball. You actually have to play it in order to actually learn it. If you just watch videos about basketball, you'll never be able to actually dribble, for example. You have to actually hold the ball and do it. So 12 says 6x minus y plus 3z equals 6. 6x minus y plus 3z equals 6. And then x plus 3y minus z equals -7. By the way, my most common mistake is it's hard for me to like focus on just writing things down like in detail and stuff because like my attention with all the like social media and everything is like super short by now. So I have to like really focus when writing them down. My most common mistake is making a mistake in writing the original problem down. Like if you don't have the right numbers written down, it's guaranteed to be wrong. So make sure that you have everything right. So double check it all. So I'm looking at my assignment again and it says 6 negative positive 3 6 x 3 negative 7. Okay, good. Third equation is 3x plus 3y minus 4z equals -2. 3, 3, -4, -2. Now that -2 looks like a z, but it's not a z because remember, anytime I do have a z, I always put a line through it so you know the difference. So that's actually a 2, not a z. Now, by the way, z stands for zebras. So you can see some zebras at the zoo. How do you solve this equation? Anybody have any suggestions? Well, first of all, you have to look at the letters and find the letters that have the smallest overall numbers in them. So, have you ever heard of the least common multiple? So how do you define smallest? Well, look at these. They have a 3 and a 4. What's the smallest common multiple of 3 and 4? 12, right?
You could get rid of the y's.
Yeah, we can get rid of the y. Yeah, what's the smallest common multiple of 3 and 3 is just 3. Right, that's really small. 3 and 6, the smallest common multiple is 6. So the y's are the smallest. So therefore it's wise to get rid of the y's. How's that? So we're going to focus on the y's because they're the smallest. They have the smallest common multiple of themselves. So how can I get rid of the y's? I have to do it in at least 2 different ways without just doing the same thing twice. Well, I'll do the easy one first. Second row minus bottom, right? So there's a second row and there's a third row. What happens if I do the second row minus the third row? So what if I do it like this? Second row, which is x plus 3y plus minus z equals -7. I'm just copying it again so you can see it like visually together. Third row is 3x plus, wait, it's spilled. My hand is getting tired of writing it again. That's my pet peeve is writing things again and again and again. But I'm willing to do it for you to help you learn. So now you can see the second row and the third row. If I subtract them, what will I get? This is going to really test your ability to do negatives and double negatives and triple negatives and things like that. So what's a positive minus a positive? It's like subtraction. So what's 1x minus 3x? Is it 2x or is it negative 2x? Negative 2x, correct. Then what's positive 3y minus positive 3y? It's 0. So that's 0. I'm going to just leave off the 0. And then what's negative z minus negative 4z? That makes this a positive. So if you do negative minus a negative, that's really negative plus a positive. So what's negative z plus positive 4z? What's negative 1 plus positive 4? 3. So it's going to be 3z. And then what's negative 7 minus negative 2? Well, if you do negative 7 minus a negative, anytime you do minus a negative, it's a positive. So what's negative 7 plus positive 2? It'd be negative 7 plus positive 2 is negative 5, right? So you can also do it on a calculator. If you go to a calculator and you type in negative 7 minus negative 2, it'll just tell you negative 5, like that. Okay, perfect. Now, we're not done yet, though. We have to think of another way to get rid of the y's that we have not done yet so far. Is there any other way to get rid of? So we have there's 3 options, I think. So imagine you have 3 different things that you can have, and you can pick 2 of them. Like if you have 3 candy bars, like Baby Ruth, Butterfinger, and Milky Way, how many ways could you pick 2 candy bars out of those 3? You could, yeah, you close your eyes, but you could pick the first 2, or you could pick the last 2, or you could pick the first one and the last one and not the middle one, right? So it's the same way with these equations because you have 3 ways to choose them. We chose the second and the third, but we could also choose the first and the second, or we could choose the first and the third. So which one should I choose? First and the second or the first and the third? What do you think? First and third. Okay, that's a good idea. First and third. So you said first and third, right? First and third. So let's write down the first one. And let's write down the third one. Oh, I made a mistake. What mistake did I just make? Yep. That's my personal the hardest thing for me is to pay attention.
Same.
Okay, the second one is x. Well, the third one, I mean, sorry. Third one is 3x plus 3y minus 4z equals negative 2. By the way, did you know that there's one thing that's worth more than money in life, and it's attention? Because if you can pay $1 billion worth of attention, you'll get more out of life than if you paid $1 billion of money. Ever thought about that? So let's try to. I'm going to try to have $1 billion worth of attention after this. So how do I get rid of now? Am I focusing on the y's or the x's? Still on the y's. So how do I get rid of the negative y and the 3y? I can't because they're not opposites of each other. So what can I do to those to make them opposite of each other? Specifically the top one. What can I do to the negative y so that it's the opposite of 3y?
You can take the first one by times 3.
Yep, exactly. Perfect. Take the first one times 3. Then the first one will now be 18x minus 3y plus 9z. And this is why attention is really important because it's just hard to focus on these problems. I think that they say by now that most people only can pay attention for less than 6 seconds. Have you heard that? Isn't that crazy? 18x minus 3y plus 9z equals 18. And then the third equation stays the same. 3x plus 3y minus 4z equals negative 2. There we go. Okay, so there's that. What happens now? Subtract. Actually, that's what you normally do is subtract it, but in this particular case, we can actually add because these are already opposites. 30 negative, not positive. So instead of actually subtracting like normal, we're actually just gonna take this one. We're just gonna take this one plus this one, like that. So what's 18x plus 3x? 21x. So in three, like if you're 18 now, in 3 years, you'll be 21. Crazy. And then what's negative 3y plus 3y? 0. What's 9z plus negative 4z? 5z, right? What's 18 plus negative 2? 16. So 2 years ago, if you were 18 now, you used to be 16. So we have two equations. Now, I'm going to focus on those equations, and we have to put all of our attention on those two equations now, not on the other ones. We have that one, and we have that one. Boom. Okay, now focus carefully on those equations. Forget about everything else in the whole world and just look at those equations. So I'm going to try to practice what I preach. Okay, can one of you write those equations down for me? Remember with them, -2, 3, and -5, and then 21, 5, and 16. Can you remember that? Do I trust you? I'm going to write them down, I guess, because I'm not sure if I can trust you. -2, 3, -5. Actually, I can trust you. I just have to be strong and independent, though. 21, 5, and 16. Okay, there we go. So I'm going to go to a new page, and I think I had -2x, right? Let me switch to a darker color. Green is kind of too bright. -2x plus 3z, -5, right? And then I had 21x, 5z, 16, correct? So you have to have faith. But when you're doing these problems, you have to have a lot of confidence, because this is like if you're having a presidential debate. If you lose your confidence, you might like lose the debate, right? So you have to make sure that you're careful and you have confidence while you're doing it. So here, I'm missing something. What am I missing? I'm missing a plus sign and an equal sign. There we go. So we gotta watch everything carefully. Okay, now which of these has a smaller common multiple? What's a common multiple of the x's? What's the smallest number that 2 and 21 both go into? 42, right? What's the smallest number that 3 and 5 both go into? 15. By the way, did I make a mistake? Did I write them down correctly or not? Which one did I write down wrong? Let me go back and check. It's -5z on the first one. So are these correct? Are these correct? Okay, let me look here closely. Hold on. -2, +3, and -5, 21, +5, and 16. I think they're correct. Okay. Now, so this one's smaller. So just remember, your goal is to get something in common. Remember that. Just like if you're having if you're like, if you are a diplomat and you're trying to like arrange a peace treaty or something like that, like a peace treaty with Russia, for example, you have to try to find something in common. Like maybe they don't like most things, but there might be something that they would like to agree with you on. So the thing that they agree with on is 15 for the z. How do I make the first z become 15 if it has 3 already? I need to multiply it by what? 5. And when you multiply one thing by 5, you have to multiply everything by 5, right? So it's -2 times 5 is -10. 3 times 5 is 15. -5 times 5 is -25. By the way, the good news is a lot of this extra work that we're doing, you can actually get rid of the extra work and just do the calculations. We'll learn about that in a little bit later though, but so.
On a scientific calculator, when you go into like functions, you have to to 0.
Yeah, something kind of like that. Like we're going to learn, we're not going to go into it very much, but we're going to learn how to do these more quickly than we are right now. But before you can do it that way, though, you have to understand how it works. Because if you don't understand this, then you won't be able to do the next part. So how do I make the bottom z become, I don't want it to be 15z, I want to make it to be the opposite, because it needs to balance out the positive 15. So I can make that 5 become -15. Multiply by -3, right? So then I'll get negative 3 times 21 is negative 63. Negative 3 times 5 is negative 15z. And then, oh, look, there's a 3 and a 16 like John 3:16, although it's not in the right order, but. So this is negative 48, right? Perfect. Now, what happens next? Any ideas? Once you get into the form where that letter, that's the common letter, crosses out, then you're good to go. So does that letter cross out now, the z's that were in common? Yeah, so let's add these up. So negative 15z plus 15z is just 0. What about negative 10x plus negative 63x? Negative 73x. What about negative 25 plus negative 48? That's negative 73 as well, actually. A miracle. By the way, just when you need it in math, there's sometimes a miracle happens. So divide by negative 73, and what do you get? What do you get? Yes, it's 1. So x equals 1. Now, the good news is that when you have done all this work, it's like the sand pile that starts to fall over, and then everything else just kind of becomes a lot easier once you've found the final answer. Once you've found the final answer, then you work your way backwards to find the smallest equation that you could possibly have that had that letter that you can plug in that you already solved for. So that's not small, that's not small, that's kind of small, but 2, 3, and 5 is really small though. So I'm going to go back to the equation that said negative 2x plus 3z. I'm going to go back to that one. Negative 2x plus 3z equals negative 5. What do you think I'm going to do with that problem? What do you think I'm going to do with that problem? I'm going to take the one that I got. I'm going to plug that in to it. So negative 2 times 1 plus 3z equals negative 5. My fault. So negative 2 times 1 is negative what? 2, correct? Man, it's too bad it didn't say 4 because then it would have been 2, 3, 4. Oops, sorry, my fault. Sometimes I write what I'm thinking instead of what I'm supposed to write. So it's actually negative 5. So negative 2 plus 3 equals negative 5. How do I get the z by itself?
2 to the 6.
Correct, exactly.
Can I read that? Like, as an answer?
It could be, but I don't know if it is. Let me find out.
Well, like, when-
Sometimes it is. I tried to give you problems usually, not always, but usually that did not have decimals. Although problem 16, I think, has 1 fraction in the answer. But that's not even the same kind of problem. Okay, so I don't think any of you should have fractions or decimals in the final one. Because I tried to have ones that were only whole numbers. But that's still a good effort though. So z equals negative 1. So I get z equals negative 1. What do I do now that I know what z is equal to? I find the easiest equation that has an x and a z in it, which is probably from the previous page. So what's the easiest equation that has an x and a z in it? How about the second one? So I'm going to write that one down. So the second one says x plus 3y minus z equals negative 7, and my brain has already forgotten what was on that other page. So what was x equal to? Let me look. 1, and z was negative 1, right? So x equals 1 and z equals negative 1. So for x, I'm going to plug in 1. And then for z, I'm going to plug in negative 1. And then what's negative times negative 1? Positive 1. So it's 1 plus 3y plus positive 1 equals negative 7. And what's 1 plus 1? Good job. So 2 plus 3y equals negative 7. What do I do next? Subtract. What do I subtract? 2. And then I get 3y equals negative 9. So then I divide by what? 3. And I get y equals negative 3, correct. So now you have to put your answers in alphabetical order. So There's the answers, and I'm up at the top of the page. I'm going to put them in alphabetical order because that makes it better. So 1, that's X is 1, then Y, and then Z is -1. They call it an ordered pair if it has 2 points. They call it an ordered triple if it has 3 points. So that's the solution to it is 1, -3, -1. Perfect. Okay, well, so there's that. Okay, I'm going to just, since we didn't do the other 2 examples that we had, I'm going to just give you a little bit of a hint. So number 13 is going to work out just like number 12 and number 11. But number 14 and 15 are going to be slightly different though. So let me give you a hypothetical example. Okay, if you ever get to a question like this, what if you got to something like this? If you get to something like 2x plus 7 equals 2x plus 4. If you ever get to a point like that, or something like this, let's just say you get to let's just say you get to 2x plus 5y equals 18, and then you get to 2x plus 5y equals 25. Does anybody notice anything about the equations that I wrote up at the top, or about the 2 equations that I wrote at the bottom? Can those be logical or not? Is it possible that 2x plus 7 could be equal to the same thing as 2x plus 4? No. Is it possible that 2x plus 5y could be equal to 18, and then in the next system of equation below it, you have 2x plus 5y equals something different? Now, anytime you come up with something that's called an inconsistency, then you immediately know that there's no solution. So all of these things like this, they're called inconsistencies. Like, have you ever heard of people trying to tell lies and like tell a bigger and bigger lie until they finally get caught? Because eventually you say something that's inconsistent. So when you have a system of equations that's inconsistent, that means that there's no solution to it. And that's going to happen in, I won't tell you which one, but it will happen in either 14 or 15. And the other thing that can happen is you can come up with something like this. Let me do a new page for this as well. What if you get to something like this? It says like 5x equals what would I do? Hold on a second. 5x plus y equals 10, and then 5x plus y equals 10 as well. And then like 5x plus y equals 10 as well. What if you're solving a system of equations and suddenly every single equation turns out to be the same? What's the solution to that? Right, then there's infinitely many solutions. Because have you ever heard of people that really say nothing, like they haven't given you any information, they just keep saying the same thing over and over again? Well, they're not giving you a solution, they're just giving you an infinite amount of information, basically. So this has an infinite amount of solutions to it. Infinite amount of solutions. And the reason it has an infinite amount of solutions is because there's 2 words you could say. These pieces of information, they're all redundant. I've misspelled redundant, sorry. Redundant. Another word that means redundant is dependent. For example, if you're a dependent on your parents, that means your parents help pay for your living expenses, right? So either one of those, there's no actual solution being created by the equations. Well, there is a solution, but it's an infinite amount of solutions. It's not really a specific solution that like has an answer. Okay, well, there we go. So now are you ready to go into a brave new world? So don't be afraid though, don't be afraid. So thankfully in college algebra, we only talk about this a little bit. If you took another class called called have any of you ever had trig or pre-calculus? Probably not because you're in college algebra, but if you went into one of those classes, you talked about that a lot. But we're only supposed to talk about this just a little bit. But the thing is, you have to realize it actually makes it a lot easier. So I'll give you an example. What we're learning now is what's the thing that you hate about algebra the most?
Numbers, variables.
Variables. That's what most people say. You hate about algebra is the variables. Exactly. who would agree that like you hate the X's and the Y's? If they just had the numbers, it'd be easier, right? Like if you had like which is easier, 25 plus 11? That's like 3 and 6, or like 25x plus 11y and everything like that. What most people hate about algebra is the letters that are in the algebra. So that's actually kind of sad though, because letters are actually supposed to make your life easier. Because if you have something big, like an unknown variable, instead of having to like write a huge number like a million and a billion, if you just had like one little letter like X, it makes it easier to work with. So that's sad but true that most people hate letters in algebra. So what if you just took out the letters? So what if you just had so what if you had, I'm going to skip ahead a little bit actually. So what if you just did an equation like problem 22, 3x plus 4 plus y equals 4, and then x minus 4y equals 36. So this equation has letters in it. So let me teach you a special method though, actually. What if I just wrote down how many x's I had in one column? I have 3x's and I have 1x. And if I just said that column number 1 represents x. Now I write how many y's I have in the next column. So I have 1y and I have negative 4y's. That represents y. And then in between that column and the other side, I draw a line that represents equals. So you just draw a line to represent equals. And then it equals 4 and it equals 36. Now notice it still represents 3x plus 1y equals 4. Still represents 1x minus 4y equals 36. But it takes you half the time to write it because next to every number, there's no letter that you have to write. So it saves you like half the time and half the energy. And it saves you the ink as well. So you won't run out of ink as quickly with your pen. Well, the question is, how do you solve this though? So this is why you have to understand how to solve the equations before in order to solve equations now. Once again, you look at the x's. So remember, this still represents x, 3x and 1x. What's the common multiple of 3 and 1? 3, right? What's the common multiple of 1 and negative 4? It'd be 4. So which has the smallest common multiple? 3, right? So all we have to do is to get the x's to be a common multiple. So I'm going to take, so do I need to make the 3, do I need to change the 3? No, because it already is common, the common multiple. What I need to change is the 1. So what can I multiply the 1 times so that it becomes the opposite of 3? Negative 3. So I'm going to multiply it by negative 3. And now my new system of equations is still going to be 3, 1, and 4 on the top. But what's the bottom row of it going to be? Negative 3, positive 12, and negative 108, right? Perfect. Excellent. Now, we're still going to do the same method as well. Once you get a column that's the same multiple but opposites of each other, you're going to add them up. So we're going to add that system of equations up, and we're going to get, what's 3 plus negative 3? 0. What's 1 plus 12? 13. And then equals, what's 4 plus negative 108? You said negative 104. Okay, perfect. Now, you can treat this system just like an equation. You can still divide by it. So we're going to take this problem, divide by what? So we have 13y right now. We have 0x plus 13y. We're going to divide by 13 to get the y by itself. And I sure hope that 13 goes into it an even number of times. Let me think. How many times does 13 go into 104?
8 times.
8 times. Okay, cool. It's always what I'm nervous about. Let's see. I'm just going to double check. So 10 times 8 would be 80. 3 times, yeah, you're right. So it's negative 20. It's negative 8, right? Negative 8. Okay. So what is 13 divided by 13? 1. And what's 0 divided by 13? So we got 0, 1, and negative 8. Oh, I forgot the equal sign. My fault. By the way, that line is not a 1, that's like an equal sign. So you have 0x plus 1y equals -8. Now, as long as you mentally know that this represents x and this represents y and this represents the number that it equals, then you don't have to, you can still accurately represent the equations. So basically we're using shorthand to do the equations with, because that line represents equals. The only downside to that is if you have a missing number, you can't just have nothing there. You have to have a 0. So let's translate this answer. What does this answer mean? So at the end of the problem, you can't do your problem like this because nobody would understand what this meant unless they're an expert like you. So what does this mean? This means 1y equals -8. So therefore it means what? Y equals -8. So
Question. What if that number doesn't go into it and it gives you just?
if it doesn't, that's what I was afraid of, because like in real life, it could happen, like you said. Well, if it doesn't go into it, you might be right. Like it could just be a fraction or something like that.
Okay.
On problem 22, it should. I picked a problem on problem 22 that even if it gets randomized, it should still hopefully come out to be a whole number. And then how do I find the other variable? So this is where it works the same as before. You find the easiest equation, which is probably the top one, 3x plus y equals 4. And you plug in the one that you know, which is y equals -8. You plug that into it. So we're going to plug in to 3x plus y equals 4. We're going to plug in 3x plus -8 equals 4. Then we're going to do what? Well, what will we do? Subtract a -8, but subtracting a -8 is the same as adding a +8, right? So then we'll get 3x, that cancels, and then we'll get equals to 12. And then you're going to do what? Divide by 3. So once you get to the end, it works the same as it did before. In fact, the whole entire problem is really the same as it was before. The only difference is you're not writing the letters beside everything anymore until you've solved one of the equations. So that's how you solve problem 22. Now we're going to go back a step. We're going to go back to problem 16. Problem 16 is where you just learn about operating on things. So before solving problems, the homework actually has you learn about the setup of it. So let's go back to 16. So 16 just says this. It says 3, 3, and then a line, and 7, and then 1, and -2/5, and then 5. So we're supposed to pretend like we don't know what that means now, and we're just learning about it. So the parentheses just means the whole problem. The line means equals. The first column means x, the second column means y, and the third column is the numbers that it equals to. So that's what it means, right? Now we're going to learn about how to do operations on that. So not like doctor's operations, not really. But this says take row 1 and switch it with row 2. That's what it says. So it's really just asking you to basically do random things. So what happens if you switch row 1 with row 2? So by the way, the rows are the things like the lines. So if I take the top line and I switch it with the second line, what would I get? I would get the bottom line on the top, the bottom row on the top, right? And then I get the top row on the bottom. So that's all you have to do. That's the answer. That was pretty easy. Okay, let's do 17. Ready for 17? 17. -9, 24 equals -36, 2, 8, -3. And this time they actually have brackets around it. So whether they have parentheses, brackets, or nothing, and just a line in between, it still represents the same thing. So this is a system of equations that this represents -9x plus 24y equals -36. The bottom one represents 2x plus 8y equals -3. And then now it says to do -1/9 times row 1. Okay, so What does that mean to do negative 1/9 times row 1? So that means take the entire row 1, which is that row, multiply it. Sorry. Take that row times negative 1/9, right? Because negative 1/9 times row 1 just means multiply row 1 times negative 1/9, right? So that's what it means. At the top row, just multiply by negative 1/9. What is negative 9 times negative 1/9? What is the number times its reciprocal? 1, correct. And then what's 24 times negative 1/9? Wow. I'm going to cheat a little bit. I'm just going to say negative 24/9. Because 24 times negative 1/9 would be negative 24/9. I know that that's not simplified fully, but we'll do it later though. What's negative 36 times negative 1/9? Well, a negative times a negative is a positive, and 36 times 1/9 would be 36/9, right? Yeah, you're right. You're too smart for me. So the next step would be to write it is 4. You're right. You're exactly right. And what negative 24/9 also breaks down. What does negative 24/9 break down into? If you divide it by 3 and 3, what does it become? Negative 8. And what is 9 divided by 3? 3. So it breaks down like that. So the lesson of this is you are allowed to multiply a row of numbers by another number. So anything you can do to an equation, you can do to these problems. If you can multiply an equation on both sides by a number, you can also multiply a row of numbers in this setup by any number that you want to. Okay, let's see. Is there anything else? Okay, yeah, let's do number 18. 18 is going to seem hard. Are you ready for it? You already did it? So let's do number 18. So ready? See if you can follow along with this. Just try your very best. It's not too bad. 1, that's not too bad, right? Negative 2 equals 4. 4 and then 8 equals 3. So that means 1x minus 2y equals 4. 4x plus 8y equals 3. Now what it wants you to do to it though is a little complicated. You ready for it? Wow, I don't know if you're ready for this. This is really complicated stuff. What it wants you to do is to do negative 4 times row 1, add that to row 2. So I'm going to give you a hint. We're not actually changing row 1 at all. So row 1 is going to stay the same. So we'll just write down 1 negative 2 equals 4. What we're going to do though is we're going to take negative 4 times row 1 though and add that to row 2. So that's what we're going to do. So can anybody who's good at thinking about things in your head? It's actually bad to do this all in your head though, but let me just show you one little quick thing. So that's row 1, right? What is negative 4 times that number? What's negative 4 times 1? Negative 4. What do you get if you take that number, negative 4, and add it to that bottom row?
0.
So a 0, right? So that's what you're going to do. So now it's bad to do it all in your head though, because your head can easily get lost. So I'm going to draw an arrow down here, and I'm going to show you what negative 4 times row 1 really is. What is negative 4 times row 1? It would be negative 4. Now what's negative 4 times the next number in row 1? What's negative 2 times negative 4? Positive 8. Exactly. Positive 8. And then what's the last number in row 1 times negative 4? It's 4 times negative 4 is negative 16. Right. Okay, now that you visualize those numbers, now you can actually see them more concretely, right? Now you're going to add those to plus, you're going to add those to row 2, which is 4, 8, and 3, right? So you're going to take negative 4 times row 1, which is this, you're going to add that onto row 2. So what's negative 4 plus 4? And what is 8 plus 8? 16. And then what is Negative 16 plus 3. Negative 13. Correct. Sweet. So the answer is 1, negative 2, 4, 0, 16, negative 13. And that's about as confusing as it gets because everything else in this section is no more complicated than that. So any questions about that? The answer is, let me put a box around it. The answer is that whole thing right there. It's the result you get after you take negative 4 times row 1 and add it to row 2. Yep. So that step right there in the box, that's the answer. And you can do it in your head if you want to. Like if you're really good at visualizing things in your head, you can just do negative 4 times row 1 in your head all the way across and then add that to row 2. But I'm not very good at doing things in my head. Let's see. Let's do like maybe one more question. I'll let you pick. Would you rather do 20? Actually, wait, this is actually a great question to do. This is going to be actually the way let's stop actually, I guess. Let's stop. I'll let you leave early unless you have questions. Do you have questions? Let's just have some question and answer time. Anybody have a question? So ask. What's the what?
Why is there, what's the two R2 stand?
Row 2.
Row 2.
Yeah, it's like the second line.
So just.
Yep.
add into the
Yeah.
top.
Yeah, if you take negative 4 times row 1, which is that's negative 4 times row 1, and then you plus to row 2. Then you add those together and you put that in row 2 as the result.
Okay.
All right, good job. So I did decide to move ahead the deadline of the homework to be a Sunday instead of Wednesday. We actually only have a few more questions to go through though in this section. So I'll look forward to seeing you again on Wednesday. Keep up the great work, everybody. Yeah,
Again, thank you so much for that.
you're welcome. But make sure you work on it hard though. Don't put it up until the last minute.
Yeah.
Because I don't want you to like try to do it during the last hour or something like that. You're welcome.
Thank you.
Great.